Today we are going to learn about areas related to circles. Before we move on to the areas, we must understand different parts of circles and the formula related to those parts. So we have center O, and from center O at equal distance we draw a curve, then this forms a circle. And the portion inside this boundary, the red boundary, is called the area of circle. Now let us have a look at different part of the circle. So we have a circle with center O. If a line passes through the center of the circle, touching the boundary of the circle at point A and B, then we call it the diameter of the circle. It can be represented by capital D or small d. Now from the center, we draw a line till the boundary of the circle, say OC, then we call it the radius of the circle, which can be represented by capital R or small r, and we know that radius is half of the diameter. Now you all know that area of circle is given by the formula pi r square. Let us have a look at this circle. If I draw a line from this center like this, and from here like this, it will divide the circle into two parts, that is this small portion, which is called the sector of a circle, and since this is a small portion, so we can call it a minor sector of a circle. And we have this larger portion which is also the sector of a circle, and we can call it the major sector of a circle. Now this minor sector, it has an angle at the center, theta, and this major sector also has an angle, that is 360 minus theta, because total angle of a circle is 360 degree. So these angles are called the angle of the sector. So area of minor sector is equals to theta by 360 degree into pi r square, and that of major sector is equals to 360 degree minus theta by 360 degree into pi r square, where pi r square is the area of a circle. Let us take this circle with center O. If I draw a line AB, that is the chord of a circle, then it will divide this circle into this lower portion and the upper portion, which are called the segment of a circle. This lower portion is smaller part and the upper one is larger part, so we can call it the smaller portion as minor segment and the larger one as the major segment of a circle. Now if I join OA and OB, I get a triangle OAB. And if I take this portion away from the circle, then this is the sector of a circle. Now if I draw a triangle on the upper portion here, then this triangle and this lower portion combines as a sector, and then if I remove this triangle from the sector, then I get the segment. So we can say that area of a segment is equals to area of sector minus area of a triangle. So we can write the formula as theta by 360 into pi r square, which is the area of the sector, and the area of triangle. Now area of triangle will be different for different triangles, that's why I have not written the formula for area of triangle. As we proceed to the question, then we will discuss the formula for different triangles. Now if I take this circle with center O, and if I mark this out, the lower portion, Then remove this, I get the upper portion, that is the major segment of a circle. So the area of major segment of a circle is the area of circle minus the area of minor segment. Last but not the least, let us take a center O, and taking this center, we draw a circle, that is this yellow circle, and by taking the same center, we draw another circle, that is the blue circle. These type of circles using only one center are called concentric circles. Now from this concentric circle, if I take out the yellow portion, then we get a ring of a circle. So the area of a ring is equals to area of outer circle minus area of inner circle, because I have taken out the inner circle from the two circles. So writing the formula, area of a ring equals to area of outer circle. Obviously outer circle meaning it will have larger radius, so pi capital R square, where capital R represents larger radius, minus pi small r square, where small r is of the smaller circle, that is the inner circle. By taking out pi common, we can write area of a ring equals to pi bracket open r square minus small r square bracket close. So the formulae to be used in this chapter are area of circle as pi r square, area of sector with angle theta equals to theta by 360 degree into pi r square, area of major sector with angle 360 degree minus theta equals to 360 degree minus theta by 360 degree into pi r square, area of minor segment is equals to area of sector minus area of triangle, area of major segment is equals to area of circle minus area of minor segment. We know that minor segment, the area of minor segment is given by this formula. So you need to first find out area of minor segment, then find out area of circle, and you need to subtract them, you get the area of major segment. And lastly, the area of a ring. Area of ring equals to pi bracket open capital R square minus small r square bracket close. Let us solve some problems from exercise 12.1. The first question, the radii of two circles are 19 cm and 9 cm respectively. Find the radius of the circle which has circumference equal to the sum of the circumferences of two circles. To understand this question, let us draw some circles here. So this is the first circle with radius 19 cm, and this is the second circle with radius 9 cm, and we have the third circle with an unknown radius x centimeter. We know the boundary of the circle is called the circumference of the circle, and we know that the formula for circumference of a circle is 2 pi r. Now the question says, if we join or if we add the circumferences of the two circles or the two circles with known radii, then we get the circumference of the third circle. So circumference 1 plus circumference 2 will give us circumference 3. Now let us put the formula for each circle. So we can name 19 cm as R1, 9 cm as R2, and x cm as R3. That is radius 1, radius 2, and radius 3. So for the first circle, the formula would be 2 pi R1 plus for the second one 2 pi R2 is equals to the third one, that is 2 pi R3. Here we see 2 pi in the first and the second circle similar, so we can take that common like this. So when you take them common, After we take out the common, we see 2 pi on the left hand side as well as on the right hand side. We can cancel them like this. After we cancel them, we get R1 plus R2 is equals to R3. So let us put the value for R1 and R2, that is 19 plus 9 equals to R3. 19 plus 9 is 28. So we get R3, or the radius of the third circle, as 28 centimeter. Let us read the second question. That is, the radii of two circles are 8 centimeter and 6 centimeter respectively. Find the radius of circles having area equal to the sum of the areas of two circles. This question and the first question looks similar, but then the first one talks about the circumference of a circle and the second one talks about the area of a circle. To solve this question again, we'll draw circles with its area. So the first circle with radius 8 centimeter and the second circle with radius 6 centimeter and the third circle with radius which is unknown to us. The blue portion is the area of circle, that is the portion inside the boundary. The red boundary that you see is the area of circle. According to the question, we have area of circle, and we know that when we join or add the area of two circles, first and the second circle, it will give us the area of the third circle. And we know that area of a circle is pi r square. Like we did in the first question, we can also do the same, that is giving 8 centimeters R1, 6 centimeters R2 and x as R3 for the first, second and the third circles. So area of circle 1 plus area of circle 2 will give us the area of circle 3. By putting the value or the formula, we have pi r1 square plus pi r2 square is equals to pi r3 square. First circle, second circle and the third circle. We have again pi common, so we take out pi common like this and we cancel pi. After that, we put the value of r1 and r2, that is 8 square plus 6 square equals to r3 square, because we do not know the value of the third radius. We know that 8 square is 64 and 6 square is 36, and 64 plus 36 will give us 100. So root over of 100 will give us 10 centimeter. So the radius of the third circle is 10 centimeter. Let us have a look at the third question of exercise 12.1. Figure 12.3 depicts an archery target marked with its 5 scoring regions from the center outward as gold, red, blue, black and white. The diameter of the region representing gold's score is 21 centimeter and each of the other band is 10.5 centimeter wide. Find the area of each of the 5 scoring regions. So since the diameter of the gold region is given 21 centimeter, so the radius of the gold region would be the half of 21, that is 10.5 centimeter, and the width of the region, each region is given as 10.5 centimeter. This is the width of the region. So for red, blue, black and white, they all are 10.5 centimeter. Now we know that area of a circle is equals to pi r square, and we have the first region, that is the gold region, which is a full circle. So area of the gold region equals to 22 by 7 into 10.5 whole square. When we square 10.5, we get 110.25. When we multiply 22 and 110.25, we get 2425.25 divided by 7. And when we divide this numerator by 7, we get the answer 346.5 centimeters square, which is the area of the gold region. Now we need to find out area of each region, so we need to find out the area of red region now. So to understand this one, first let us find out the radius of the next region, that is the red region, which is given by radius of gold region plus width of the red region. So we know that radius of gold region is 10.5 centimeter and width of each region is 10.5. So when we add 10.5 and 10.5, we get 21 centimeter. So the radius of the red region is 21 centimeter. Now area of a red region or the ring, as we discussed earlier, is equals to area of red circle minus area of gold circle. So we have this gold circle and we have this red circle. When I remove the gold circle, I get the red region. That is why area of red circle minus area of gold circle. Area of red circle equals to 22 by 7 into 21 whole square, because the radius of the red circle is 21 centimeter. So the square of 21 is 4 into 41. So 22 into 4 into 41 gives us 9702 divided by 7. When we divide this number by 7, we get 1386 centimeters square. That is the area of the red circle, not the red region. It is the red circle, that is from center outward. Now we will find out area of the red region. That is area of red region or the ring is area of red circle minus area of gold circle. We have already found out the area of gold circle. So by putting the value of area of red circle and area of gold circle, we get 1368 minus 346.5. When you subtract this, we get 1039.5 centimeters square, which is the area of the red region or the red ring. Now we need to find out area of the blue region or the blue ring. Before that, we need to find out the radius of the blue circle, which is given by radius of red circle plus width of the region. By putting the value of radius of red circle, that is 21, and that of blue region width is 10.5, so when we add them together, we get 31.5 centimeter. Now area of blue circle is equals to 20 by 7 into 31.5 square, because we know that area of a circle is equals to pi r square. After squaring 31.5, we get 992.5, and multiplying 22 and 992.5, we get 21829.5 by 7. After dividing the number by 7, we get 3118.5 centimeters square. That is the area of the blue circle. We know that we need to find out area of the blue region or the ring. So area of blue circle minus area of red circle will give us the area of the blue region. By putting the value of area of blue circle and that of red circle, we get 1732.5 centimeters square. That is the area of the blue region. Now we need to find out area of black region. So for this also we need to find out the radius of the black circle. So the radius of black circle is 42 centimeter. Again, putting the value in the formula of a circle, we get 22 by 7 into 42 square. The square of 42 is 1764. Multiplying that number by 22, we get 38808 by 7. After dividing this number, we get 5544 centimeters square. That is area of black circle. the area of black region or the ring is given by area of black circle minus area of blue circle, and by putting the value we get the area of black region as 2425.5 centimeters square. We need to find out area of the last region, that is the white region. Again, we will find out the radius of the white region or the white circle, that is area of black circle plus width of the white region. 42 plus 10.5 will give us 52.5 centimeter. By putting the value of pi and r, we get 22/7 into 52.5 square, and when you square 52.5 we get 2756.25, and multiplying this number by 22 we get 60637.5 by 7. Dividing this by 7 we get the area of the white circle as 8662.5 centimeters square, and the area of the white region or the white ring is given by area of white circle minus area of black circle. By putting the value of white circle and black circle, we get area of white region as 3118.5 centimeters square. So the area of the gold region is 346.5 centimeters square. Area of the red region is equals to 1039.5 centimeters square. Area of the blue region is 1732.5 centimeters square. Area of the black region is equals to 2425.5 centimeters square, and the area of the white region is 3118.5 centimeters square. I will be uploading more videos on areas related to circles, that is minor sector, major sector, minor segment, major segment. Thank you for watching this video.